a member of the International Professional Engineers and a life member of the Indian Society for Technical Education. He is also a registered graduate engineer with the Board of Engineers, Malaysia. His contributions to research are commendable, and he has secured various grants for projects that push the boundaries of knowledge. He has developed various sustainable biodegradable polymer composites, which reflects his commitment to the advanced science and technology. So I take this opportunity to thank the organizing staff for giving me an opportunity to introduce the professor. And with this, I hand over the session to Professor Dr.Elamaran Jeyamani, sir. Sir, welcome you.
Thank you, ma'am. Shall I start now, ma'am? Sure. Okay. It's okay. It's clear now? Is it clear now? Shall I start now? Generally, when we can talk about materials, they are like metals, polymers, ceramics, and then the recent development is composite materials. What happened during this material production, we are extracting the raw material from the mother earth, that is the raw material in terms of ore. By means of refining process, we are getting into different metals. During refining process, it gives lot of CO2 emission. Either it is a metal or polymer or ceramic. During their extraction, during their production, we are giving lot of CO2 emission to the mother earth. In terms of pollution, we all know that pollution in terms of air pollution, water pollution, as well as land pollution. Due to the technological developments, urbanizations, currently we are facing the problem of sound pollution. You can see in the process, for any product to be in the market, these are the sequence. We need to input like energy, water, raw materials, consumables. Industry 1.0, mechanical equipment powered by steam. Because those mechanical equipment powered by steam is converting water into a steam state. We need lot of heat energy. What happened? We are burning lot of coal. Coal again we are getting from the earth crust. By burning that coal is a chemical energy. We are converting it into heat energy. That heat is used to convert water into steam to power the mechanical production in the industrial 1.0. So when we can produce the steam, we start to give lot of CO2 emission. When it comes to industrial 2.0 and 3.0, again we need electrical energy. Currently we are producing electricity based on that gives greenhouse gas effects. Now the problem. What I want to say here now. Starting from industry 1, going for solar, wind, tidal, geothermal like that. So, from industry 1.0 until industry 4.0, we are polluting our mother earth. So, how to be sustainable? That's what today's topic, especially computational methods, how to involve on this. What is climate change? Everybody is facing, everybody knows that. What does that mean? That climate change refers to long-term shift in temperature and weather pattern. So, climate change is the world's most pressing challenge. Every country, even take Malaysia, India, US, UK, Russia, China, they are focusing on how to mitigate the climate change. What are the causes? Human emissions of greenhouse gases like carbon dioxide, nitrous oxide, methane and other gases. So, these are the main causes. For example, rapid industrialization, energy use, agricultural practice, deforestation, consumer practice, livestock, transport, resource extraction, pollution. These are the causes for climate change. What are the effects? Of course, we are facing every day: rising temperatures, rising sea levels, unpredictable weather patterns, extreme weather events, land degradation, loss of wildlife and biodiversity. What is the main cause? You can look at the picture here. The important CO2 emission is in terms of gigantons. The first rank goes to power, because still we are relying on electricity production by using fossil fuel plants, that is thermal power plant, either coal or natural gas or natural oil. Second one is the transport. The third one is manufacturing, building and industry. So these are the important players for CO2 emission. That CO2 emission causes global warming issues. Due to that, we are facing climate change. Okay, how to mitigate this? Because we all know that how to mitigate that. That's what the term sustainability. United Nations developed the term sustainability. This sustainable development focuses on what are the needs for the present without compromising the ability of future generations to meet their own needs. The meaning will be, we need to use the natural resources for ourselves, and at the same time we need to keep the resources for the coming generation. That type of development is called as sustainable development. So how to achieve the sustainable development? Because currently all the manufacturing industries or any factory, they are focusing only on profit. They are focusing on economic profit only, but they never care about what is happening to the people surrounding the industry, what is happening to the environment. So this sustainability focuses on three important pillars: economy, social as well as environmental. So each and every industry hereafter not only to focus on economic profit, they have to focus on what is happening to the ecosystem, the people surrounding us, what is happening to the environment. That is what is sustainable development. Further, United Nations developed 17 sustainable development goals. By 2030, we have to achieve these 17 goals. These 17 goals divided into three important pillars. First one is economic pillar, second one is environmental pillar, third one is social pillar. For example, economic pillar: no poverty, zero hunger, good health and well-being, decent work and economic growth, industry, innovation, infrastructure. Under environmental pillar, we can go for clean water and sanitation, affordable and clean energy, responsible consumption production, climate action, life below water, and then life on land. The last one is important as well as social pillar: quality of education, gender equality, reduce inequalities, sustainable cities and communities, peace, justice and strong institutions, and then partnership for the world. So each and every country is working towards achieving these 17 sustainable goals. Even universities also focusing these days sustainable development weeks, and then they are doing a lot of activities towards making an awareness about what is meant by sustainable development goals. For that, because as engineering, we are some of them mechanical engineers or electrical engineers, materials engineers, energy engineers. We are various disciplines, but how to focus, how to achieve the sustainability? For example, what is sustainable material? Currently, as I said before, we are using different types of materials like metals, polymers, and ceramics. Those are conventional materials. During their production, during their extraction, even during their use, it use lot of emissions, lot of pollutions. So what is the term sustainable material? You can look at the definition. Sustainable materials are materials they do not strain the environment during their production, use and disposal. So a material during their production, during their use and during disposal, it will not give any other strain, will not give any pollution, carbon neutral. That type of materials are sustainable materials. We cannot go directly into sustainable material, but we can replace conventional material by sustainable material. Currently, we need a structural application, non-structural application. For example, to make an aircraft, to make an automobile, to make spacecraft, we need structural application, strength-wise. At the same time, non-structural, decorative purpose. So currently, researchers are replacing some of the parts like 20%, 30% by sustainable material. For example, well-known automobile industry, you can take BMW, you can take Toyota, you can take manufacturing. In manufacturing plays an important role for every country because it compensates for gross domestic product, that is GDP of any country, because it gives lot of economic profit. At the same time, you can use the second line here. However, this sector has also contributed to inefficient utilization of energy. You can look at the term inefficient utilization of energy and increased carbon emission. So, manufacturing sector contributes a lot of inefficient utilization of energy as well as resources. The industries like metal industry, paper industry, chemical industry, petroleum and coal-based industries. So, it gives a lot of CO2 emission. So, we have to move from exactly the term sustainable manufacturing. You can look at the definition. A systematic approach to eliminating waste by optimizing use and selection of resources and technologies, thereby lessening the impact on the environment. You can look at the definition. A systematic approach to eliminating waste by optimizing use and selection of resources and technologies, thereby less amount of pollution. Okay, in terms of air pollution, water pollution, or whatever may be the waste. So that type of manufacturing is called as sustainable manufacturing. For example, sustainable manufacturing includes things such as making products using less. Sustainable manufacturing from the conventional way of making a material as well as making the product. Now, what are the clean technologies? For example, you can see we are talking about renewable energy as a clean technology. Apart from this, there are various other techniques also available under category of clean hydro. These are renewable, but it's also one of kind of clean technologies. Apart from this, we can go for energy efficiency by means of smart grid, by means of making electric vehicles, autonomous vehicles. This also comes under the category of clean technologies. For example, clean technologies include technologies for wastewater treatment, recycling, solid waste management, solar panels, and then wind turbines. So, clean technology is an umbrella over all the technologies, include all the technologies focusing only towards pollution-free or completely biodegradable form of energy. What is industrial ecology? Because we are thinking that material and energy flows through the system to find inefficient waste. So, as a responsible citizen, environmental waste, because it's an important concept as well, into the air, what could harm the human health and environment. See, you can think about as we are using responsible way in terms of energy. Even you can take example in a house. We are responsible for the water use. We are responsible for the energy use. You can see the definition. Any unnecessary use of resources or substance released into the air, water or land that could harm human health or environment. Now, what is emerging business? You can look at the term here. In 1990, population was 5.3 billion. In 2015, population was 7.3 billion. You can imagine 2030, 8.5 billion, and then 2100 expected to be staying in the only one Earth surface. See the term here. The world population growing exponentially. There is a finite supply of non-renewable natural resources. Because whatever the population growth, we are living in only one mother Earth. We are not moving to moon. We are not moving to somewhere else. We are still under 2-3 decades before. For example, in 1980s or 1990s, what is the price of 1 liter petrol? You know what is the price of 1 liter petrol now? Because the demand non-renewable resources, but population increases. How to compensate? So we have to move from non-sustainable to sustainable way of living our way. How to do that? For example, currently what we are doing is linear economy. We are taking the metal or whatever the resource from the earth crust, we are making the product, we are using it, we are using water, then we are disposing the wastewater. Similarly, it goes to metals or minerals or coal, whatever. Currently, we are using linear economy. During linear economy, it generates a lot of disposal waste. But we have to move from linear economy to circular economy. Materials in a circular economy are collected and reused after each use. For example, we can make product, use the product, collect the waste, transform the waste into useful some energy and then reuse it. If we do that, we can able to reduce the amount of waste and At the same time, we can able to consume less amount of natural resources. How to do that? For example, you can see the value chain. Currently, linear economy, take, make, use and waste. We are producing a lot of waste. But currently, we are dealing recycling economy because we know the concept of 3R principle. Recycle, reuse like that. You can see take, make, reuse and then waste. But we have to completely move from how to achieve this. We can achieve like this waste collection to the plant. We can convert waste into form of useful energy, fuel, gas or electricity, so that we can able to make zero waste. But it is very, very impossible. Without generating waste, it is impossible. But what this concept says is try to reduce the amount of waste generated. Try to use the amount of energy used. That's what the main intention. Try to reduce it. We cannot make it completely zero waste, but we have to reduce the amount of waste generated as well as reduce it to the mother earth. That is the concept of 9R framework comes to circular economy. What is 9R? From linear economy to circular economy, we have to go from recover, recycle, repurpose, remanufacture, refurbish, repair. That makes smarter product use and then manufacture. For that, industrial 4.2 and then circular economy. We know that currently we are in industrial 4.2. It is a combination of various technologies as well as manufacturing. For example, cloud manufacturing, additive manufacturing, disruptive technologies such as big data analytics, cloud computing, artificial intelligence, and the Internet of Things plays an important role to achieve the circular economy concept. Now, how is computer science? Because mainly the conference topic was computational sustainability. For example, we have various disciplines, mechanical, electrical, civil, electronics, robotics like that. But what is the duty of software engineers? What is the duty of computer scientists? So here, computer scientists can and should make important contribution to help address key social and then environmental challenges. So what they want to say, computer scientists is an important, must play an important role towards sustainable development. How computer scientists or computer engineers can contribute towards sustainable development? Yes, it is possible. There is a new field of computational sustainability brings these efforts together. You can see that the computational sustainability, how engineers can develop various tools and techniques to implement the sustainability or towards sustainable development. For that, computer scientists, they know that technologies like machine learning, optimization techniques, remote sensing, decision making, so that these type of tools can help predict and forecast what is happening in the future. Those data will be useful for towards the sustainable development. What exactly? You can see that techniques from computer science and related fields such as information science, operational research, applied mathematics and statistics to manage the balance between environmental, economic and societal needs for sustainable future. By using computer technologies or computer tools and techniques so that we can balance the three important pillars of sustainability. One is economic pillar, environmental pillar and then social pillar. How to do that? So some computational sustainability in developing computational and mathematical models, methods, tools for decision making and policy making. You can see, for example, by using computational mathematical tools and methods, we can go for decision making, policy making concerning the management and allocation of resources for sustainable development. How to do that? We have various important pillars. For example, these are the three important things on sustainable computational. The first one is optimization, dynamic models and simulation. Second one is multi-agents, crowdsourcing and citizen science, data and machine learning. So we can able to relate three important pillars: renewable sustainable energy and materials, biodiversity and conservation, balanced environment and social needs. How to do that? By means of various tools. First one is IoT, Internet of Things, because we all know that Internet of Things. For example, currently we are using lot of fossil fuel, petrol vehicles, diesel vehicles like that. But we can move from electric vehicles. You can see that the electric vehicles have been taken as a sustainable replacement for ordinary fossil fuel powered vehicles. Replace petrol engines by electric vehicles. So that what happens, we can bring down the greenhouse gas emissions, and then we can move from autonomous vehicles. These autonomous vehicles are also notable trend these days to replace our conventional vehicle into autonomous. All these autonomous electric vehicles are possible by means of IoT, Internet of Things, as well as information communication technology. So you can see that these technologies are involved in the field so that we can able to reduce the amount of fossil fuel use. For example, this is a smart house, how smart lighting, remote control appliances, smart vehicles, smart power consumption of energy. Game theory. We are using game theory for various applications. For example, various researchers on game theory, they are working towards sustainability. For example, tracking and prediction of poaching, threats in African wildlife, confronting illegal fishing efforts in Indonesia, promoting tiger conservation in Southeast Asia. These are various researchers doing on research, because I got this information from the research papers. For example, the game theory also plays an important role to mitigate some of the environmental challenges. And then we can use data mining. For example, data mining is commonly applied with regard to sustainability. When we can talk about wind power, wind resource is important. That is also possible by using data. Data mining and big data, they are used to predict. For example, you can see big data and the related techniques have been topics of studies in context of improving social and environmental sustainability in supply chains. For example, in disaster resilience, in societal development, in urban transportation. So, various researchers are working on towards sustainability by using this type of ICT tools as well as this type of computer software and hardware. AI, we know that currently AI is placed an important role everywhere. So AI compensates for lack of experts, because these days AI thinks what we need to do it. So the lack of experts will be replaced by AI. So AI compensates for lack of experts and collects better data for improved decision making. For example, AI in conservation and experts are increasing utilization. Of course, machine learning is predict fluctuations in wind power. You can see there is a lot of tools are used by the researchers to predict something to improve the sustainable development. For example, you can see agent-based modeling and stochastic optimization modeling, infectious disease in dynamic population. For example, COVID and they use these techniques to predict it. Similarly, you can go for remote sensing used in many applications like monitoring, deforestation, species distribution modeling, poverty mapping, and then natural disaster prevention. So, remote sensing also plays an important role toward the sustainability. When it comes to the sustainable computing, there are two parts. Information technology is an enabler. What is the enabler is? Which helps to address environmental concerns. At the same time, IT is itself responsible for causing environmental damage, because we know about a lot of electronic waste. So, that is called green in IT. So, we have to understand the difference between green by IT. So we have to involve IT to mitigate the sustainable challenges. At the same time, green in IT means IT also contributes towards sustainability, towards pollution. So we need to balance these two. How to balance these two means by using many studies. They are doing like sustainable human computer interface, sustainable data centers, and then energy related issues. By this taxonomies, we are using Bloom's taxonomy, Solo taxonomy, and fixed taxonomy. So, by adopting the learning keywords, for example, system thinking competency, anticipatory competency, normative competency, strategic competency, collaboration competency, critical thinking competency, self-awareness competency, integrated problem solving. These competencies makes an awareness towards sustainability among the students, so that we can able to achieve our objective of sustainable development. By this, I can conclude. This type of computational sustainability enables economic progress, minimize pollution and waste, to support future generations by enabling sustainability by means of preserving natural resources. By this, thank you very much. I hope I finished with time limit. I just rushed it. Can you hear me?
Yes, sir. Thank you so much, sir. Participants who are available in the meet can ask any questions to Dr. Jeyamani.
It is within time limit, ma'am. I'm not using any time.
No, sir. Thank you so much for your presentation, sir. I'm Dr. Sudha, one of the conference chairs. This is a pleasure to meet you online.
Sure, sure.
Yeah. And
Because I'm not ready, I'm taking more than 15 minutes. That's why last minute I rushed with you.
that's okay, sir. It was a very interesting lecture. I think everyone enjoyed the lecture. Thank you so much for your presentation.
Yes, ma'am.
So, if there are no questions from the participants over here in Pondicherry Technological University or from the participants who are already in the online meet, I think we can wind up the plenary session and then we'll start the paper presentation. On behalf of Pondicherry Technological University, on behalf of the conference team of ICACIC 2023, my profuse thanks to you, sir, for having chaired this plenary session. We'll start the paper presentation in a short while. All the participants, please enter your presentation session links. Now, the participants of this session alone, with the sir, everyone is sir as the session chair, may just hold on to this meet. The remaining people can go to their respective Google Meets and start their presentation in their respective Google Meets. Thank you so much, all of you. Thank you, sir. Please be with us, sir, because we'll start the presentation immediately now, sir.
Thank you very much, ma'am. Thanks for the opportunity, ma'am.
Yes, sir. Thank you.
As a alumni for paid time, happy to share my knowledge, ma'am. Thank you very much. Thanks for the opportunity.
Just a moment, sir. Which batch are you, sir? Many of my batch. Okay, right, sir. Right, sir. We have Professor Burne from Chemical Engineering Department, sir.
Yes.
Okay.
I know Alamurthy, my brother is Alamurthy and then Palanichami.
Sir, we'll start in 2 or 3 minutes. No problem.
Definitely, I will.
Yes.
Sustainability is our base. All confidence. At the bottom is top.